Hello friends, in this tutorial we will be dealing with different types of pressure system, that is atmospheric pressure, gauge pressure, vacuum pressure. So you might be uh, hearing all these words: atmospheric pressure, gauge pressure, vacuum pressure. So we will see what is atmospheric pressure. So what is atmospheric pressure? Atmospheric pressure actually the earth is surrounded by an atmosphere. So let's take this as our earth, and it is surrounded by an atmosphere. It is surrounded by an atmosphere like this, and this atmospheric air this atmospheric air is applying a force on the earth's surface. This, let us take it as the air column. This air column is exerting a force on the Earth's surface, and this force is in the unit area is called the pressure. So the atmospheric pressure is the pressure acted by the atmospheric air on the Earth's surface, and generally at the mean sea level in normal condition, this value is equal to the atmospheric air value is equal to 10 point. The value of the standard atmospheric pressure at the mean sea level is equal to 10.1043 into 10 raised to 4 Newton per meter square. It means that in 1 meter square area, 1 meter square area, the air from the surface to the top of the atmosphere is exerting a force of 10.1043 into 10 raised to 4 Newton. Do you know what is this value is? Let us take it into the kilogram masses. So into 10 raised to 4 Newton per meter square. If you, and how the force, the Newton is converted into kilogram, we have 1 kilogram is equal to 1 into 9.81 meter per second square. This is equal to 9.81 Newton. So you know this value. So how can you convert Newton into kilogram? Divide it by the 9.81. So the pressure is equal to 10.1043 into 10 raised to 4 divided by, for the sake of time, let's take this value as 9.81 as 10, generally approximately 10 kilogram per meter square. Okay, so this 10 4 cancel out and 10 raised to 3. Oh, this is value 10.1043 into 1000 kilogram per meter square. So you have 1000 kg is 1 ton. You have 10.1043 ton per meter square. So what is actually means that in 1 meter square area of the surface at the mean sea level, the air is exerting 10.1043 ton of force, and when you compare it with the value, the weight of a car, generally the weight of a car is 2 ton or 3 ton, and placing 5 or 4 cars in 1 meter square area, and that is the actual force applied by the air on the earth surface. And do you know why this you cannot feel, or we cannot feel this? It is because that at the let's take our example. This is we the human beings. Okay, so the force exerted by the atmosphere is 10.1043. And why are you not crushing out by this huge amount of force? It is because we have the internal pressure equal the same amount of internal pressure is acting in the other direction. It is from the outside and this from the inside. We have inside the same amount of internal pressure acting, so that you there is a balance between the two forces, and this will cancel out. And you can see the example of, if you go in the higher latitudes, the atmospheric pressure, due to lesser air density and less depth, atmospheric pressure get reduced, and for a sudden change your inner pressure will be more, and due to that imbalance, the you may see that there is a slight crack in the blood vessels, and from you can see the tiny amount of blood coming out of uh, from your nose. It is because the imbalance between the internal pressure and the external pressure. So I hope that you got the answer. So this is atmospheric pressure. Now we will deal with the absolute pressure. Absolute vacuum gauge and vacuum pressure. So what is this three pressure? For that we will take a graph. Do it with here we can mark the pressure. So you're taking at the pressure at the point here, one point here. Let's take it as B, and from the complete vacuum you are measuring the pressure from the complete vacuum. This will be absolute pressure. Okay, so now you consider a point where at the surface of the earth, where you can find the local atmospheric pressure from the complete vacuum. Consider a point. Let's take it on the surface of the earth. So this is barometric pressure or local at atmospheric pressure. It is at the surface of the earth. Now you measure the pressure of any substance based on the surface pressure, based on this atmospheric pressure. Then let's take a point A. Then the pressure at A is taken from the atmospheric pressure is called the gauge pressure. Gauge pressure from the base taken as the atmosphere is called the gauge pressure, and if this is positive it is called the positive gauge pressure, and if it is taken at B here, or at the negative less than the atmospheric pressure, then it is called a vacuum. So what is the importance of this? See, generally we things we measure the pressure in the uh, in the in the earth surface. So in every substance or every object, the uh, air pressure, the atmospheric air pressure is subject applying in every object. So it is important to measure the difference in pressure, and or only due to that difference something changes happens. So when you consider an object and the manometer measures the pressure of 14 bar or 40 newton per meter square, it is actually means it is more than or it is the value of the difference between the actual pressure and the atmospheric pressure. Okay, so now we have the equation, the absolute we have absolute pressure is equal to atmospheric plus gauge, or atmospheric minus gauge. So if it is the value is greater than atmospheric, then the absolute pressure is atmospheric plus gauge, or it is less than atmosphere, it is negative. Okay, so what it means, the manometer measures a pressure of 40 bar. It means that it is 40 bar greater than the absolute or atmospheric pressure. And if it measures a vacuum of 20 bar, it means that it is less than the 20 bar less than the atmospheric pressure. Okay, so in generally, for the convenience, we take the gauge pressure. And if that is because when you that the barometer is open to the atmosphere, the pressure, the reading in the barometer will be zero. It is adjusted to the local atmospheric pressure, and there is no difference between the pressure. So if only a difference is there, then only the pressure gauge measure the pressure gauge will read a value. Okay, so I hope that you got the answer, and if you like the video, please subscribe the channel and share the video. Thank you. We will see in the next video. Thank you.